Okay, today we're going to work on solving some real world problems involving decimals. And this problem actually has a mixed number in it. But since we worked on turning fractions into decimals earlier in the week, I think this will be really good practice for us. So I'm going to start by reading this. Miss Brocker brought 7 and 232 thousandths pounds of candy to share with the grade level. Miss Rob's class ate 3 and 17 thousandths pounds. Mr. Hinkey's class ate 2 and 3/8 pounds of candy. How much candy is remaining for Miss Brocker to share with her class? Okay, so this is actually a really tricky problem. It involves a couple of steps, but what we're trying to figure out is how much is remaining or left over. Okay, we know we start with 7 and 232 thousandths pounds, and we're going to take away 3 and 17 thousandths pounds and whatever this decimal of that mixed number 2 and 3/8 is. Okay, so I'm going to actually, I think the best thing for us to do would be to subtract what Miss Rob's class ate from our total right away. Okay, so I'm going to do that. We're going to use those same kind of skills strategies we've been using this week for addition and subtraction of decimals. Start by writing my decimal point for my answer. That helps me stay organized. I'm going to start by writing my total, 7 and 232 thousandths pounds. And from that, we're going to subtract what Miss Rob's class ate, which is 3 and 17 thousandths of a pound. Okay. I'm going to go ahead and subtract. We don't have to fill any of those placeholders in. I cannot take away 7 from 2, so I'm going to come over to my hundredths here. I'm going to borrow one and regroup it into 10 thousandths. And 12 minus 7 is 5. And 2 minus 1 is 1. 2 minus 0 is 2. And 7 minus 3 is 4. Okay, so this is what Miss Rob's class ate. Now we still need to subtract what Mr. Hinkey's class ate, but because we have decimals and a mixed number of 2 and 3/8, we're going to use what we used earlier in the week and turn this 3/8 into a decimal. Remember, the way we do that, because both fractions and decimals are pieces of a whole, you're going to take your numerator and put it into your division box, and you're going to break it up into 8 pieces. Here's where you say you cannot divide 3 into 8 equal groups and have a whole number answer or quotient. So you're going to put a decimal in your quotient. I like to draw my little arrow there to remind me to put my 0 in my dividend. And now, how many times can 8 go into 30? The answer is 3. 8 times 3 is 24. I'm going to get 6 left over, and we're not going to put that up as our next decimal in our quotient or as a remainder 6. We're going to keep dividing. And how many times can 8 go into 60? 7 times, which is 56. Subtract there, 4. I'm going to pull down another 0. 40 divided by 8 is 5. 5 times 8 is 40. 0 left over. Okay, now I'm going to put this 375 thousandths with this whole number 2. So here's how much Mr. Hinkey's class ate. They ate 2 decimal point 375 thousandths. And we're going to subtract that from what we already subtracted from our total that Miss Rob's class ate. And whatever is left over, this is going to be Miss Brocker's class. That's how much candy we get. Okay. And I'm going to start right over here in my thousandths place. 5 minus 5 is 0. And I can't take away 7 from 1. Now you have 2 options here. A lot of 5th graders, it's up to you. You can either jump all the way over to your whole number and borrow for your tenths and your hundredths. Or if you think that's too much to do at one time, that's okay. You can just come over here to your tenths and borrow 1, turn that into a 1. 11 minus 7 is 4. Okay, now right here, looking at my tenths, I know that got a little bit unorganized, but I have 1/10 minus 3/10, which I can't do, so I'm going to have to come over to my wholes right here. I'm going to borrow one of them and regroup that over here. And 11 minus 3 is 8, decimal point. And now I have 3 minus 2 is 1. Okay, so here's how much Ms. Brocker's class has left over. Okay, last problem we're going to practice our learning target with today. Jamel measured the heights of 3 of his best friends. Below is a chart of their heights in meters. If they stood on top of one another, how tall would the stack of Jamel's friends be? Okay, so what we need to do, looks like we're going to, they stood on top of one another, how tall would the stack be? So we're going to just be adding all of these numbers. Should be pretty easy. Start with my decimal point, decimal point, decimal point, and 1 for our sum. I'm going to just plug these in. Remember, we're doing addition, so that the order doesn't matter. I'm just going to copy them from here. 1 and 243 thousandths meters, 9,242 ten thousandths meters, and 1 and 9,823 tenths, hundredths, thousandths, ten thousandths, hundred thousandths meters. Okay, now that we're done with that, I am going to add in placeholders. I'm going to do those with a different color. Okay, it just helps me stay organized. And 1 in my 1's over there. Okay, now I'm going to start adding all the way over here. 3 plus 0 plus 0 is 3, and 2 plus 2 is 4. I'm going to have to do some regrouping here. I think it's easier to add 7 and then 8. 7 and 8 makes it 15, but you can do whatever regrouping makes friendly numbers for you. I think it's easier to add 9 plus 1 is 10, plus 4 plus 2 is 16. And then right here, I think it's easier to make a 10, and 2 is 12, and then 3 1s is 3. Okay. Not forget my label there, meters. So we have 3 and 26,543 hundred thousandths meters.